talk a bit about moving away from mite control. And this is something which Steve Riley talked about yesterday, or one specific aspect of it, and I'm going to give a little bit more sort of background and some of the other techniques that you can do this. Because as I explained yesterday, really, this is the only long-term solution. It's allow your bees to sort themselves out and allow them to basically use their natural ability to solve the mite problem. And hopefully this will probably set you well ahead of the game if and when tropical aelapse gets here, because we think the similar mechanisms will be able to deal with tropical aelapse as well. So I'm going to go on the offensive a little bit, but I mean, is this the face of modern beekeeping that we want to give to the public? Not really, in my opinion. And actually, it's quite hard to find pictures of people doing oxalic treatment properly with the proper equipment. But I've been fortunate enough to be around for a very long time, and those of you who are old enough will remember when Varroa first came, nobody wanted to put chemicals into their colonies. They were producing honey for human consumption, and the last thing that they wanted to do was to put any sort of miticide or chemical into their colonies to control the mites. And they wanted a silver bullet. They needed something that was going to solve the Varroa problem. And a lot of beekeepers ended up getting out of beekeeping. They lost their colonies because they refused to put miticides in their colonies. What's really surprised me now, 30 years on, that we've actually swung the pendulum completely to the opposite direction, where everybody's so normalized about putting miticides into colonies that it's just, this is the beekeeping. And trying to say, well, actually, we do have the solution now. We understand it scientifically. We've got really good evidence from beekeepers in the UK and also in other places around the world that haven't been treated for decades. And people are really fearful of change. So it's trying to reset that balance and giving some confidence. And I really like this cartoon that this Polish guy does, because, I mean, this really, to me, sums things up. If you've got to protect yourself, and don't kid yourself, using formic acid, oxalic acid, these are acids. These are, when people say they're soft chemicals and things, but they're still quite nasty. And we heard yesterday a really excellent talk about the dangers of pesticides and interactions. We really don't know what's going on with these. So we can avoid them. It's great. We're all producers of, foodstuffs. And even though the levels may be extremely low in some of these, it's better not to use them to get back to beekeeping where you don't have to treat. So there are lots of treatment controls, and it seems to be what's happened with tropical aelapse again is now all the effort is on how do we control it, how do we kill it. Nobody seems to be going, well, what about Apis cerana? Apis cerana should not, should have a problem with tropical aelapse. Apis cerana doesn't have tropical aelapse, but it's a new pest for it. Somehow it deals with it, and we don't understand why, and not many people are studying this at the moment. But it's probably using the same mechanism how it deals with Varroa. So it seems to be something that particularly countries that can afford it, we go down this, we create a problem, and then we try and solve the problem using pesticides and chemicals. And yesterday's lecture on that really pointed that out, how there's 17,000 whatever pesticides we use. And we often forget that bees are an insect, and these pesticides do affect the bees that we use. It's just the quantities that we use are different, and so the effects are less on the bees, but there's still a bee. So it's really, at the end of the day, if we've got a solution which doesn't involve using it, that's great. And the other thing is that, as I was saying yesterday, that there's always this co-evolution. So these mites, Varroa, they don't have a huge amount of genetic variation because they live in a very stable environment, but they're still under selective pressure. When they're being killed by pesticides to help control them, there's still a good chance that they'll develop resistance. And sure enough, back in the 80s or the early 90s, they developed pyrethroid resistance in Europe, and that spread very quickly throughout Europe because there's still people moving bees around, and it caught the beekeepers out because they weren't expecting it. And it caused a lot of colony losses, a big wave of them again. And the reason for this really rapid increase in colony losses is because when we initially got Varroa, it took about 3 years for the viruses to sort of get going and colonies to start to die. We had like a 3-year leading period. But all colonies now have deformed wing virus. It's already present in your bees, circulating either via the mite or actually just naturally through food and through sperm, through the queens at very low levels, but it's there. So if the mite populations increase, there's no lag anymore. And so the colonies will die very quickly once the mites reach the threshold, which they can do quite fast. And that's what happened with the pyrethroid resistant, and that caused huge problems. And it will continue to do so. There is often talk about that you can revert back to some of the chemicals that we'd use if you don't use them, or you can change them, one chemical 1 year and one chemical to the next. Again, this all depends on the mechanisms and the cost of the mechanisms. And this is just a quick example, is that we know for pyrethroid resistance now in mites, there are basically 2 mechanisms that have been shown. One is very expensive for the mites to do. That's basically to detoxify enzymes. So it has to produce these, it degrades these enzymes. That's biochemically very expensive and difficult to do for them. They will do that. And then effectively, if there's no pesticide, they will stop. There's no selective pressure against it. They'll stop producing these detoxification enzymes because they're expensive. So in that case, if this mechanism's available, you can then switch back and they may still work. They may not be quite as effective, but the mites will. Then you'll get a bit of a break in time. However, if you get something like the sodium channel, where it's just a single change in the structure has caused the actual physical size of the sodium channel to get smaller, and that blocks the pesticide or the miticide getting into the cell, there's almost no cost to that. So that won't revert. So it all depends on the mechanisms, and it's actually quite detailed. And for beekeepers, it's a bit hit and miss because you don't know what the mechanisms are in the mites that you're dealing with. So usually when they've stopped working, mites have got resistance, you move away from them, and I don't think many people are using pyrethroids now. And this has happened again. We had pyrethroids resistant in the United States, but it was never reported. Strangely, it was around the time CCD was happening, and we knew it was spreading around and it would catch beekeepers out. What's happened last year in the US, and it was really good. This time they really got on top of it very fast. USDA, Jay Evans's group, were there collecting samples. They didn't want to be caught out like CCD, where they really didn't understand what was going on. Huge numbers of losses, as you can see here. 1.6 million colonies lost. It's about $600 million worth of them. People will straight go say it was the commercial, but even the hobbyists lost 50%. Some beekeepers were actually treating for Varroa every 2 weeks. The one thing they were not doing was monitoring. And one thing that they found, although this hasn't been peer-reviewed yet, is that all the mites that they looked at were amatraz resistant. And amatraz is something that's used really widely in America. So it was the same thing that's happened, where effectively resistance came, the beekeepers missed it, and I mean, it's crazy. You're treating all the time, but you don't monitor if the things are effective. I wouldn't say it's lazy, it's just what they do. And in the States now, since Varroa came, their average losses are 40%. That's every year. It's a really unsustainable industry. And unfortunately, as was shown yesterday, every country, every continent in the world, their beekeeping managed colonies are going up except for the United States. And this is a real sort of key problem. It's possibly part of the commercialization, but also it's getting these problems, and oxalic acid and formic acid and all the other treatments eventually there will be issues with these as well. So as I said yesterday, Varroa resistance is this long-term natural solution. It's letting your bees do this. It's been around for an awful long time for what now, 40 years in Brazil. We have really strange situations now occurring where the influence of the Northern Hemisphere still often predominates. And there was people treating Africanized bee colonies in places like Costa Rica. There was a poster, and we were saying, well, why on earth would you treat Africanized bees? They're naturally resistant. And their answer was, well, it's because that's what America does. And it's like, but you've got bees that don't need treating, so why are you doing it? They just, sometimes people look for somewhere else and think, well, that's what they're doing, that's what we should do. And like in Australia now, even though they don't have mites in some places, they're already going down the treatment and get locked into this treatment cycle. So this really is a long-term solution. So how do you get there? And I'm sure most of you are interested in this. So first of all, we know that Varroa resistance traits in the UK are widespread. So this is just some examples of people that haven't treated for at least 8 years. So 5 years, we would say that these colonies are Varroa resistant. Some of the green dots are these, some of the case studies that we've asked people to do, and I'll give a plea out. Anybody that hasn't treated for 5 years or longer, who's in the audience and would like to write a case study for the Varroa resistant website, please do, just email us and we'll put it up. And it just helps other beekeepers read how certain beekeepers got to it, many different ways of getting there. And we've done several surveys over the years, and also the BBK surveys. And one thing which is slightly, I think maybe disappointing in some ways, and I apologize, I just added in the last data from that came out just last month, is that the number of proportion of non-treatment beekeepers in the UK is about 25%, and that's pretty much stayed the same over the last 5 years. So I was hoping it might be a little uptick, but it hasn't, and I'm not sure why that is, where people are it stayed pretty much the same. But that does equate to a lot of people, and we know for others, like going into this data, that people have not treated between 6 and 15 years, or it's more than that now. You know, there's around 7,000, maybe 8,000 beekeepers in the UK, so it is a sizable number, and they're scattered throughout the whole of the country. I was really saddened to hear yesterday in the workshop we were running that there was a young beekeeper just started, they were 1 year in, and they had asked something in their local bee association about, you know, the possibility of resistant bees, you know, could they buy queens or something like this? And they were shouted down very, very vehemently by some of the older beekeepers saying, you've got to treat, you're a bad beekeeper if you don't treat, etc., which used to happen in the past a lot. I thought we were getting over that stage now, but it's still, unfortunately, in some of the beekeeping groups. And I think that's education is really important on this aspect. Just a few examples of treatment-free beekeepers. Ron Hoskins was the grandfather of this, really, in the UK. I am as guilty as everybody else when I really didn't believe that he wasn't treating for many, many years. And eventually, yes, the bees were studied, and he was even using some of the things that Steve Riley used now. Towards the end, he'd worked out that he didn't quite understand it, but he worked out that bits of dead pupae on the floorboards were important in his colonies, and he started recording them down as well. There's a big group in Lancashire where they don't treat, and there's some other, there's many, many people around the UK. The most famous one, and it's actually the largest known area in Europe, which is now, I think, 17 years, is this group in North Wales. Clive and Sean Hudson have been shouting about this for a very long time. They're one of the very few beekeepers that have stood up from very early on saying, look, we collected feral colonies and we've stopped treating. They're doing very, very well. We don't lose particularly more colonies than anybody else. and they've basically converted other people, like-minded people in their area. And this is some old data from theirs. It's 6 years old now, but they have this sort of 500 colonies with about 100 beekeepers. And we had a really nice case study from this group. So when they get a new beekeeper comes into their association, they're given a split from one of these resistant colonies and told not to treat them. And this person got 2 splits. The colony survived over that winter. They then split them and got, I think, 4, then 6 colonies. And at the end of his case study, he basically says, if somebody asked me how to treat for Varroa, I wouldn't know how, because I've never had to do it. So he was a new beekeeper that had been helped by his association. And I think that's a really sort of gold standard we should attain in other beekeeping associations. So there's lots of people in Europe go to this area to have a look, talk to Clive and thing. And I think the big thing that I hear back from bee scientists is the bees are just like any other bees. Okay, they have the resistant traits if you look for them, but they're just normal. People think that resistant bees are special. They're not. They're just normal bees, produce normal honey. They die from normal other problems. But so this is a really nice area, and I think the Hudsons are trying to get this into some sort of conservation area now. So this is from Steve Riley, and I really like this because what you've got is that you've got these 2 sort of stable situations. So you've got the stable situation where you've got Varroa treatment. So this is where you have no selective pressure. You're reducing the mites by giving them miticides. So your bees are susceptible to Varroa. You need to treat them. And then you breed from bees with low resistance to Varroa. So there's no selection for Varroa resistance. And then, of course, your bees are susceptible, so you need to treat them. And you go round and round and round in this circle. And as long as you're locked into this, you cannot, it's very difficult to escape from this without losing your colonies. The other system is what people are enjoying when you have Varroa-resistant bees. In Latin America and Africa, your bees are already resistant to Varroa, so you don't need any treatment. So you're spreading the resistant traits. So you have high selection for that resistant traits, and you go around and round in that cycle. And as we know, in the green cycle, as they're going round and they get better and better at reducing the mite population, which gets lower and lower. It will eventually stop at some point. It might go to the point where they drive the mites entirely into the drone brood, because the mites will make a decision that it's just not worth them going into their worker brood because they're going to be detected and removed. And so selective pressure on them will favour the ones that only go into drone brood, as what happens in Apis cerana. Interestingly, and I didn't explain it yesterday, is that we don't have direct evidence that actually they're doing this behaviour in drone brood. For whatever reason, they don't seem to do it. There's 3 studies and they all show the same thing, that they're not actually targeting drone brood. They will uncap and investigate drone cells, but it's not targeted at Varroa. We don't know why, but it's very similar to Apis cerana. So how do you get from the treatment cycle, which many of you will be locked into, to the Varroa resistance cycle? And I think it's a fear of change, and it's also the loss of colonies, especially if you have a small number of colonies, or the loss of money if you're a big commercial operation. So the first way, so there's 3 basic ways, I think, of managing the transition. So it's a managed transition. I will not advocate going cold turkey. Do not stop treating. If you stop treating and you're really playing Russian roulette with your bees, you have no idea how resistant your bees are. You might get lucky, and there's some case studies and people I talk to where they've got ill, unfortunately. They've maybe gone into hospital for a bit, they've been recovering, or they've had to look after an elderly relative. The bees have got forgotten, and they've gone back a year or 2 years later to think all their bees are dead, and actually they're not. They're doing quite well, they seem to be coping on their own, and they think, wow, it's amazing. And then they've realized they can get away without treating them. That doesn't always happen. So if you just stop treating, you risk just losing all the colonies, because once one colony starts collapsing, then mites will probably, if it collapses, the mites just move next door, and any resistant traits that you've got could be simply overwhelmed. So one of the methods is basically collect swarms from long-lived unmanaged colonies. This is what the Hudsons did. This is what happened in Hawaii. To a degree, this is what happened in Cuba. Many beekeepers have done this. And I'm going to have an excellent talk after me today by Joe Ibbotson, who's done this. So he's going to give you first-hand experience of going along, seeing what's happening in the wild. I think we all probably know now of feral colonies that have been there for many, many years. Nobody's treating these colonies. They're surviving very well on their own. And so they probably have high levels of resistant traits, or at least better resistant traits than the colonies that you're treating. So you can get a leg up from this. And this works really, really well. You still need to monitor your colonies just because you don't know the history of that colony. And as I said, at the moment, without monitoring, you really don't know whether them colonies have the resistant traits or not. But this is a really good step up of collecting these long-lived, unmanaged colonies. Requeen your colonies from a friend with locally resistant bees. So we know that there are lots and lots of people that have not treated their colonies for many, many years. And if you can get some brood, some queens from these beekeepers that are local, because local bees are always best, then again, this is going to really help you accelerate that process. I suggest beekeeping associations now, for the people that used to vilify in the past, hasn't treated for 15 years, they should be actually getting to talk to their association and offering to help out to basically spread their Varroa resistant traits within that association. And what we were surprised at, that almost every association in the UK has somebody that hasn't treated for many, many years. It's just taking that where they were vilified at one time and giving them the confidence, which is now backed up by science, that actually they were ahead of the game. You know, these are the people who actually could really speed up and get you off the miticides very, very quick. And we know this because we've actually done the experiments to show that a locally mated, so that's a resistant queen that has a resistant trait with resistant drones, if you take that queen and put her into a colony, even if it's a colony with non-resistant workers, that colony will become resistant when the new queen produces her workers. So we know that the queen that's locally mated, so it's mated with drones which are also resistant, effectively carry them traits across. Although it's the workers that do this behavior, we know the mechanism, because it arises quite quickly, will be under environmental influence, so selective pressure, because it only takes several years for this to happen. It'll be what's called an epigenetic mechanism, which is just, it's not new genes, it's just having the genes there, but just expressing them more. And you can think of it as a really simple thing. Yesterday we were talking about there's these really small, very specialized group of bees called sniffer bees. And so if you basically express the genes to produce slightly more of these bees or make them more sensitive, you increase their hygienic behavior, you increase their ability, their accuracy to detect the infested cells. And we already know that all colonies, or not all colonies, all populations or apiaries can do this. So it's just making them do it slightly better. And the queen can do this by these epigenetic mechanisms, just overexpressing or just increasing the things which benefit that colony. And if they don't, then that colony dies. That's natural selection. That's what's happening in the wild. So taking the queens works really, really well. People will ask me about the drones, and there's lots and lots of discussion about this. Nobody yet has done the drone experiment, where we've basically taken drones from susceptible colonies and then crossed them with queens from resistant colonies and vice versa to see the effect of the drones. The issue with the epigenetics is that it means that various epigenetic mechanisms is the drones could actually have no role in this at all. They could have a 100% role in it, or they could just have 50-50, or they could have any measure of it at all. However, flooding the area with resistant, or drones from resistant colonies is never going to be a bad thing. There's no downside to it. We don't really need to fully understand. If you're importing semen from VHS or resistant colonies to try and get things started, then you really need to know the importance of drone. That experiment, as of yet, hasn't been done. But since we don't really do artificial insemination in this country, then we don't need to worry about it. All these populations are all open mated. We don't fully understand why, but it's just a fact. And we're way ahead of what's going on in places like Germany at the moment, where they're using single drone insemination. But unfortunately, nobody really knows the effect of the drones. But let's just assume we know that drones are really important in the system. So flooding an area with resistant drones is always going to be good. You're always going to be hedging your bets. So one thing that we can't explain, but it's just the fact, it's just the data, is that there's this argument that you can't, there's no point trying to breed resistant or select for resistant colonies if everybody else around you is treating. And there is some caveats to this, but when we actually look at the distribution in the UK of people are treating and non-treating at whatever level, so that's sort of postcodes or MBU things, or just from the survey data, pretty much everywhere in the country has people that are treating and not treating that are very close together, even within the same location. How that is possible, we really don't know. It may be that the drones have very little effect, so you're not losing this dilution. It may be that, from what Joe's going to say, is that the feral population is by and large resistant now. We don't know this, but they could be having a big influence on helping maintain, and people are maybe who are treating actually may not need to treat as much because in fact they're getting the resistant traits from the local population. We don't know, but the fact is people can keep resistant bees and non-resistant bees in the same location. So don't worry if you're surrounded people are not treated. There are other issues. One of them being that even resistant colonies can have problems. We long knew that if you take a resistant colony and move it into a non-resistant area, it would often die. And I've seen this now, and we've modeled it, so we really know what's going on, is that what happens if you get a large reinvasion of mites, which is quite rare, but occasionally can happen from a collapsing colony, and if the infestation rate gets above 40%, or nears 40%, then of course the resistant bees are detecting and removing very efficiently up to 40% of the brood. And they then kill the colony. They're just doing the right behavior, but by removing too much brood, the colony just can't survive. So I've seen this happening in America. So we sometimes have to be careful, and again, this leads back to monitoring. It's quite a rare event, this reinvasion, but it can happen. So there is these huge numbers of trees, and Joe's going to talk about more than this. These are just ancient trees, and as Joe very well pointed out to me, these are just, they're on a register. There's lots of other suitable trees. At the moment, there's about 2% of these in the southeast of England which are occupied. I suspect that will go up. There's about 40,000 wild kinds, so there's plenty of spaces, and this is just in the ancient trees. And then there's these really nice studies going on in the UK, which Joe's going to talk about, and also in Galway and other countries, where they're looking at these free living colonies, and they are basically have to be Varroa resistant because they couldn't survive otherwise. And they're going to be a really important source either for you to collect colonies from, or for them drones to come out and to help sort of saturate the area with the good traits. So we've got collecting swarms, requeening, and then I'm not going to talk about, because Steve did this probably very well yesterday, but keep looking, selecting for, if you want to go down this selection route, looking for the traits, monitoring, and then in that way transition off your treatments. This is something just very, very simple. If you want to start down this road, then basically just reduce the amount of treatments we do. I'll explain in a minute, but we're all pretty much over-treating for various historic reasons, or reduce its effectiveness. So if you reduce its effectiveness, then that will help the bees. It's getting a balance where you need enough mites for the bees to learn to detect and remove them, which is a learning process, but not enough mites to kill them. The important thing is when you start to reduce your treatments, you need to increase whatever monitoring you do. Because if you don't increase that, you're not going to actually understand what's going on in your colony. And it's amazing to me that most people say, oh, yeah, I don't see any mites, but I still treat twice a year. And it's like, well, why? If you don't see any mites in your colony, why are you treating? So do IPM. Treat when you need to treat. And I mean, this is, you'll have seen this yesterday for those of you at Steve's talk, but I really like this slide. Then you've got these colonies. He's just doing simple mite drops from the bottom boards. This is after a couple of years of the selection program. Obviously, there's an issue with Hive 8. You know, the mite population is increasing rapidly, but the other ones are not. So you get rid of Hive 8, you give it to somebody you don't like, or whatever, or a treatment beekeeper, or you requeen it from the ones that are you know, the hives that are doing quite well. You just need a ranking system, and then you just take your best colonies and replace them with the worst colonies. Sorry, the other way around. The worst colony, replace them with your best colonies. It's quite simple. But one thing that came out is that it's key for monitoring, and the current monitoring advice is very mixed. So this is from the National Bee Unit, from the last Varroa leaflet, and they've got multiples for the Varroa drop, and then the threshold, which is the really key thing. This is had a number of mites that kill a colony. This is down to 1,000. Now, this is really low, because when we actually did all the work way back many years ago, it was actually set at 2,500. And the NBU said, well, we just want to be a bit more cautious. And when I left, they knocked it down to 1,000. So if you're using this, everybody's over-treating, because you're trying to keep the mite levels way too low. And then there's information about adult bees. There's no information about worker brood, I'm not sure why. And then the information about drone brood, that effectively, if it's greater than 5%, you need to treat urgently. And frankly, it's just bullshit. That would mean that every colony in the world, be it resistant or not, would need treatment. Because Varroa levels in brood, drone brood, always exceed 5% pretty much at some time during their time. Mites flood into them, flood into the drone brood, even in resistant colonies. And we think it's an important mechanism, actually, where they're doing drone trapping. Because at the beginning of the drone brood cycle, there is huge numbers of mites that have been waiting to go in there. You get multiple invaded cells, lots and lots of them, and they reproduce really poorly. So again, they lose a reproductive cycle because of competition in cells. It's something we've seen in Cuba, we've seen it in South Africa, and we can't really, you know, we haven't studied it in full detail, but yeah, it was something that was really surprising, where you get these huge levels of drone brood, and I saw it in Mexico, actually. So when I was first studying in the 1990s, a beekeeper came up to me and said, look, just have a look at my colony, and we unforked some drone brood, and it was packed with Varroa. I mean, absolutely heaving with it. And the beekeeper in me said, well, God, you're going to have to treat this colony. It's in a real bad state with, you know, that level of drone brood infestation. But the scientist in me said, well, believe the data, Steve, because these will survive without any treatment. We were studying these long-term colonies. And I said, well, the scientist says don't treat. And he had no option. He couldn't really treat because he didn't have access to treatments. And the colonies survived. We didn't understand it then, but we think we understand it now. That it's sort of a natural mechanism for drone trapping. So the advice has become really, really mixed and difficult. Long story short, effectively, the NBU said they lost the Varroa calculator, which is some work I did many, many, many years ago. It took 3 years of a lot of detailed work to make this damn thing. It was completely useless, except as a really good mug holder. I'll admit that, because it was too complicated. I mean, look at it. It's like some slide rule from and I don't know, they wanted it round. They just said, we want a round one. Anyway. And just to give you some sort of background into it, the Varroa calculator, we basically built a big model. So, and it was really quite complex. So this is just the simple model for the bees. So we had things like the worker population, the temperature, and the degrees, the sort of degree days. That affected the number of eggs the queen laid, and obviously the eggs go into drones and workers. You've got adult bee survivorship, and then the brood survivorship at different stages, and that goes into adult survivorship, and then you've got the basic, the bees that emerge, and then how long they live. And we had this whole thing ticking through day after day. So we had this bee model that was built on lots and lots of data from lots of people around the world that had collected. And then we took the bee model, which was that little tiny thing there, and then we had a really complex mite model we'd also built. And then eventually with Brenda, we were able to work out the effect of the colonies that were the viruses, because when you just had a mite model, there was nothing to kill the colony. The mite population just grew and grew and grew. So we had the viruses in there, so we were able to do this quite complex model and put everything in and build the first real sort of illustrative model about how things worked. And although it's quite old, I think it's worth going through again because it explains how the calculator works. So this is quite a complicated thing to grasp. But effectively, each one of these little blocks at the top is a month. This is what's happening in your bee population. It's April, May, June, July, August. And along here is their age distribution. So if we look at this group of people, well, I think we're sitting somewhere here on the age distribution. We're all quite old. Very few young people in the audience, which would come out here. And so in the sort of now, in April time, you've got your winter bees just dying out, and then you've got your few new bees just coming in. Obviously, in May, pretty much all your winter bees have gone, and then you've got your new bees being born, and so you've got lots of new bees and some old ones, and that number increases as we go through the year. So we get to August, then September, when you basically, they stop producing the new bees, and the bees start to live longer, and then your winter bees have been produced, no more bees are pretty much produced, and then them bees just basically get older and older as they go through the year. And then hopefully, when you get through to April, you have enough winter bees left to start the whole cycle over again. Do you sort of understand how that's your age distribution? And that's all generated from the model. We just input the data, and that's what we got out. And then what we can do then is have a look at the effect of the virus. I'm just going to do deformed wing virus here. So it's exactly the same thing. It's exactly the same variables. But all we're doing is we're just putting a small number of mites in, which will then affect the pupae, and the pupae then don't live quite as long. And then mites that have been infected as pupae are shown in blue. So you can see there's a very small proportion of the actual bees have got infected with deformed wing virus at higher levels, so they have effectively a shortened length of life. And as the colony starts to get down into the sort of this time of year, where you have this special period where your brood population is decreasing, the mite population continues to increase, then you have a really high infestation level, and you get quite a lot of the brood at that age. These winter bees going into winter are actually infected with the virus. And then them bees start to die out. So by the time you get to sort of November, January, midwinter, you don't have any of these bees around. So all the bees that were infected with deformed wing virus have died out. The problem now is your colony's only got 9,000 bees in it rather than 22,000. So by the time it gets to spring, pretty much has died out. And that's just putting in, I think, 2,500 mites into the colony. So it was the first time we were able to show how a very small proportion of mites was able to kill a very large population, and in temperate climates. And so using them models, we were able to sort of put together the Varroa calculator. It's pretty complicated. But thanks to somebody in the BBKA who asked me it'd be really nice for you to redo the model. And luckily with my son, who's a bit more computer savvy than I am, which is quite funny because I said, well, can we build a model like a calculator type thing? And he said, well, what do you want it to do, Dad? And I said, well, I need to have something like have 12 months and some different levels of different ways to calculate things. And he's like, well, just tell me how many months, 12 yet? And he just tapped on his computer. And within 5 minutes, he'd got some basic code and a basic calculator. And I'm like, well, how the hell did you do that? Are you a genius? He said, no, I just used GP chat, Dad. God, where have you been all these years? And even my eldest son was just blown away. And between the two of us, we were able to sort of put this thing together. So now it's exactly the same. I need to update it slightly, but it's still the same as it was, but it's really, really simple to use because all the complicated maths is hidden behind it. So all you have to do is basically put in the month of monitoring, put in whatever monitoring method you use, whether it's worker brood infestation or mite drop. It will give you some other things it will require. Very simple, you just put them in, calculate it, and then it will basically give you the estimated mite population. The threshold is now back to 2,500, which is still conservative, and then it'll give you some suggested actions. So in this case, you've got high mite levels, but no need to treat at the moment, continue to monitor. So this was done in August, so maybe September, go on and do that. So you can make informed decisions. There is quite a large Q&A along with it to explain things, because it's as with anything, it's not perfect. There's lots of assumptions in there, but it gives you a guide. The more you monitor, the more information you're going to get, the more informed decisions you're going to have. So this is based on the Varroa resistant website that's there. There's a page on it, and have a look at it. I've even got a mite calculator Gmail account. So if anybody has any issues or discover anything really weird that it shouldn't be doing, they can email me. And up to now, we know at least a couple of thousand people have visited it, and we've had no questions. I've had 2 things from Australia asking me, well, can you do an Australian version? Which we can. We just have to flip around the months, basically. So as I say, there's caveats with it. It just gives you estimates, but at least it's better than the current information. Some of it's similar to what the NBU says because they're using my old data. Some of it actually, it's all based on the old stuff. And we did an article for BBK as well. So one of the big things, or the big worries, that fear is, do resistant colonies suffer from higher winter losses? It's that fear thing. You're told time and time again, you stop treating, your colonies will die. So what's the actual evidence from this? So first of all, I'll go straight to the source. The NBU data, they published a paper. Their data showed this. These are colonies that are non-treatment, these are winter losses, 2 different measures of them. It's quite a complicated data set, but effectively there's really no significant difference. There is if you take stuff at the ends and show that this is significant from that, but effectively pretty much all the same. So it's no different from their data, that if you don't treat from their data set, actually you weren't losing many more colonies. The BBK data is really interesting, and I'm not going to shy away from things that don't support my view, is that consistently over the last 4 years, non-treating beekeepers have reported higher losses, between 5 and 10% higher losses than those that treat. Now, I really don't know why this is, or I'll give you some ideas, but seems to be it's a consistent result. This is not something, there's something that underlies this. So when we look into the data, we ask the beekeepers what's the reasons for their losses, and in the years it was asked, actually Varroa is not now giving the reason of losses, be it treatment or treatment-free. It's less than 7% of beekeepers say there's an issue. And those that are in 2023-24, they asked a different question. Do you see signs of deformed wing virus, crippled bees, this type of thing? And again, most people didn't see any signs of this, whether they're treatment or treatment-free. It's actually slightly higher on the treatment-free. So what's really the problem here? So winter losses, it's really starvation, weather, which effectively is the same thing, queen issues. And often we're taking the eye off the ball, I think, where we assume, oh, you're not treating, it must be Varroa. But actually, it's possibly something else. It's starvation now, particularly with the climate change, the way that we all know that what's happening is that, you get to February, the sun comes out, it gets really warm, your bees come out, they start rearing brood, they're using the stores up, and then it snows. This hot-cold cycle, because of the way the jet stream's now operating due to climate change, is causing real problems for insects and our bees, as people know. And so bees are starting to starve because you're using the resources up at the wrong time of the year. And there's a lovely study done by the Swedish government, unfortunately I don't think it'll be published, which showed that a direct correlation between the amount of food at the beginning of winter that was put onto bees and their survivorship. Those that had more food on the winter, before winter, survived better than those that had less on it. So we often, I think, we just make an association rather than actually think about the root causes. So it just may be that treatment-free beekeepers are not feeding them enough because they think, oh, my bees are fine, they're dealing with Varroa. And actually, yeah, that's one problem, but there's others. There's also other data, and I think Joe will show some more. We have to be a little bit careful about this because we're comparing particular beekeepers with fairly small numbers against national data, which is very large numbers. But what it all shows is that beekeepers are not being treated, and Joe will show this for the feral colonies as well. There's really no big difference compared to those that are treating. So this fear doesn't actually exist. The data doesn't support it. And Gary Brook did a really nice meta-analysis. So this is where you take all the data, and this is the best way of doing things, from all different studies and have a look at it. And he found that basically only 11% of colonies survived 5 years without any treatment and management. So that's the same thing I was saying before. If you basically decide just to go cold turkey, there's possibly a 90% chance you're going to lose all your colonies. You just don't know, so you need to do this monitoring. But colony losses, basically, if treatment was just stopped, but you did some sort of swarm capture, colony splits, this is what's happening in nature, where things are swarming, colonies are dividing, you're getting brood breaks. They were less because you're buying the colonies time to learn. But the really important thing, once established, and this is once you get to that transition-free where people like Steve Riley are now and many other beekeepers, treatment-free colonies can survive the winter colony losses, which is 7 to 17% big range, which is similar to that of treated colonies. So there's really no difference. So all the evidence from many countries and many studies show there's no difference between colonies that are resistant versus colonies that are treated. So that fear should really not exist anymore. And the final thing is education. This is really important. We saw this in Hawaii, that basically beekeepers telling other beekeepers and scientists telling beekeepers, basically getting education through so people are educated, reading and making informed decisions. So one of the really things we were pleased that the BBK exams now include Varroa resistant questions in there. It's not to say that you've basically, you have to be a zealot and go down this line. It's just to be aware of it. A quarter of the beekeepers are not doing it. And again, it was something a beekeeper said to us. A young beekeeper came up to us one day and said, look, we've done all our exams and it's nothing about what you're talking about. So what do we believe? So we went to the BBK and said, look, this is a situation. Maybe you should just start putting these in, and they've done that. So this is good. It's starting to open up that debate. It's just so they can learn about these things. Use locally adapted bees. There's so much evidence now about locally adapted bees being superior, being better than things that have been brought in. There's lots of information. Steve Riley's book, there's this new book that's come out from Poland, which is now in English. Tom Seeley's given this a really nice review. There's stuff about raising resilient bees. Again, the website is there. It's got scientific papers. For me, the case studies are really important. It's got the monitoring calculator on there as well. one thing that, to me, and I know Steve will be embarrassed about this, Steve gave a talk last year. It's had 24,000 views. This is not now something that's hidden away in the closet. People are generally interested in resistant bees. There is a movement. There is a swell. We saw this at Apimondia. We saw elsewhere. It's inevitable. You know, there is a tidal wave coming, very slowly. So you're either sort of, you know, things will change over time. There is a real interest there. And it's not just in the UK. We are ahead of the game. People are coming to this country and are amazed at how many treatment-free beekeepers we have, considering we use open mating. It's all a bit haphazard, the way that we do things. But for other countries that are much more organised, it's not quite the case. But we've got people in quite a lot of groups in America, in Scandinavia, all throughout. They've got these either breeding programs. The big thing we're missing in this country is queen supplies. We don't have enough, well, we don't have hardly anybody that supplies genuine resistant bees. They should start doing this locally, because we'll never stop the queen imports coming into this country until somebody can supply them. So somebody can supply 50 queens or 100 queens that are Varroa resistant, get them traits out there. That's our big stumbling block in the UK. So suggestions for getting started: monitor Varroa regularly. Monthly is really ideal, but do as much as you can. Keep records. Understand what's going on in your colony. If your mite fall is low, just don't treat. There's no point. You're wasting money and you're wasting time. I know you're used to it. Just go with that gut feeling and monitor, and then treat if you have to, but don't treat if your mite falls low. Manage Varroa numbers in the colonies that are not coping. So as I said, give them away to a friend. Kill the queen. Just get it out of the system, because it's only going to cause you problems in the future. Look at your frames. When you're going through, looking for that recapping behaviour, chewed out pupae, take photos. Just start looking at your colonies a bit more, get a real feeling from this. I think Joe will talk about this a lot more. Make increases, raise queens and drones from your best. It's really simple beekeeping. You don't have to do really complicated queen rearing. You know, I do queen rearing for idiots, which is literally take a frame of brood out, I'll stick it in another colony, I'll split a colony. I'm really lazy if I'm going to do these things. And it works. The bees sort themselves out quite nicely. Work with others. I'm sure Steve said this. It's really important. The fear thing is massive. If you're on your own, it's much easier to cave to, you know, your fears. Oh, they're not doing so well. There's problems here. If you work with others that have the same goal, you can go down the pub, you can discuss it, you can be a bit more measured, you can get an opinion from everybody, and then make a group decision. Share your genetics, share your queen, share your best. Encourage keeping local bees. I've said this. We just know this works. Again, the scientists. And be patient. Don't expect this to happen overnight. And when I'm working in China at the moment, and the guy was like, well, I need resistance by next year because I've got a grant application to put in. I'm like, it's not going to happen, mate. I'm sorry. It just won't happen that quick. We need to start doing this in an ordered way. Give it 2 or 3 years, yeah, we might see some big changes. But just be patient. And the final thing I'm going to say is just treat less. Everybody that's treating, I can guarantee you're over-treating. You don't need to be wasting your money and your time. But monitor more. The tools are there now. They're not perfect, but they're as good as, what surprised me, I did that monitoring, that calculator 40 or 30 years ago. Why hasn't anybody else done it? Or something similar in the meantime? And it's because it's not easy, I think. But there was a nice thing came out in American Bee Journal saying that it was still actually valid for most things, so that's good. So anyway, treat less, monitor more. And again, I have to thank the beekeepers for funding all the work that we've done that I'm talking about, because all these scientists that have gone on to study COVID and bees and other things around the world are all originally funded via contributions through BDI and BBK, which allowed us to leverage funds for other things.
There's a clip that was taken from Live at the Hive, which was absolutely genuine. I found uncapping in my colonies that I didn't know was there. Anybody can do it. Anybody can do it. So just go and have a look. If you're not too sure what you've got to look for, then you'll see it. And there's really a case study of somebody who'd done it, online. So anyway, questions, please.
You talked about the winter colony losses of 34%. But in fact, if you actually look at that data, and certainly look at the data from your 2023 paper, only 10% were established treatment-free. So, in fact, about 20-odd% of those beekeepers may not be established treatment-free. So that's probably part of the explanation.
Yeah, I mean, that's true, Gary, is that unfortunately when the surveys have been done, they don't ask how many years that beekeeper has been experienced, but sure, a lot of the beekeepers who are just starting out, who just go cold turkey, will lose this. So it is an overestimation, so you're quite correct there.
I'm just interested in your comments earlier that the resistant bees didn't seem to be uncapping drone brood, and yet there's a huge amount of mites found in drone brood. Now, we're encouraged also to make more drones. Are we actually perpetuating the mite situation? I think that's what I'm trying to say.
Yeah, so this is a bit of one of these noodle twisting type things. Often it comes up in bee research or any research where it doesn't make logical sense to us as people. But it appears that what the bees are doing is that they're not targeting the drone brood. And we've seen really high infestation. So we know when the drones start to be produced, the mites flood into them. I mean, they've been waiting, and this happens in Apis cerana as well. They're waiting for their opportunity to reproduce up to a year. They flood into these cells, and you get many multiple infested cells. If you just have a single mite in the cell, yes, it'll produce 5 offspring, and it's really productive. But as soon as you start getting 2 or 3 mites in the cell, the number of mites they produce really drops off because there's too much competition. You've got 18, 20 plus mites in the cell, and they compete, and so their reproduction drops off a cliff. So actually, when you get multiple mites in the cell, their reproduction is really low. So in fact, it's almost a form of natural drone trapping. It's reducing the reproductive output of the mites simply by encouraging them to come into the cells. And it's really strange, and we don't know why, but with drone brood, you can have one cell with 6 or 7 mites have invaded it, and the cell next door to it hasn't got any. There seem to be certain drones which are more attractive to the mites than other drone cells. We've no idea why this is the case. But once you get these multiple invaded drones, then their reproduction goes. And we actually did this tried an experiment in Africanized bees. So we worked it out theoretically that it was the drones that were really important in this system, because we were looking at the mite populations over a year's period. And in fact, the mite population went down when the drone brood was present, not the opposite. And we were able to show, sort of mathematically, this was due to this competition effect. So we designed an experiment. And what it was is that we had to keep Africanized bee colonies, 10 colonies, without them producing any drone at all for 3 years. So that was our job, was to prevent drone brood. And the theory went, if that was the case, the mite populations in these colonies would actually increase in these Africanized colonies. And I tell you, it is nigh on impossible to keep a colony without drone brood. We tried, we cut the drone brood out, any drone brood appeared, we got rid of it, that was fine. But then the buggers would put it in between, on the edges, between cones, or everywhere they could stick a few cells in. And once that had happened, the mites flooded in, and the effect came on. So we failed, basically. We needed a dedicated beekeeper who would spend every day or every week going in and doing this, and it just never happened. So we never actually were able to prove it. But that's the theory. There's a good theory behind it. They're effectively drone trapping themselves. So it works for us to cut out the drone, but the bees are doing it themselves.
My association arranged a, quote, healthy bee day with 3 NBU inspectors. where there was very interesting discussion around these issues. Their contention is there are no wild bees, feral bees. All that there are escaped, swarms that escape from our bees that we keep in hives. What's your view as to the existence? Are they right or wrong?
They're wrong. And I think...
And on what basis then?
They are correct going back. So there was a survey done in 2010 where they looked at feral colonies and matched them with managed colonies and used wing venation to show there was no difference between the two. And the assumption was, and I think they were right at the time, is that most of the colonies that were feral were coming from the managed colonies. But that's 15 years ago. Things have changed. And the thing is that, as Joe will show you very convincingly, and what's happening in Galway and what's happened in Cuba and Thailand and South Africa, is the feral populations bounce back and they have a massive advantage. I'm not saying every colony that's feral basically is resistant, but if it isn't, it dies out and it's replaced by one that is resistant because they have this huge selective advantage. So they're incorrect. And I understand some of the aspects from the National Bee Unit, and the reason being is that they get called out to a colony that's sick or unhealthy, and the first question they'll ask is, are you treating for Varroa? And they basically say, no, I'm not. Well, that's what's killed your colony, and that's the end of the story. How many colonies are they called out to that are not treated but are healthy? None. Because why would they ever call an inspector out to them? So they see one side of it. They see colonies which are dying. And making that assumption that that colony died, like the data that we get from the BBKA, because you're not treating, that colony must have died to Varroa. Actually, that may be the case, but it's probably more like to have a small effect because very few beekeepers are saying it's Varroa. It's probably some of the bigger ones like starvation. It may be that there's other things in there. So I understand the NBU's situation, but they need to wake up and look at what's actually happening and what the data says and what the beekeepers are saying. I mean, explain North Wales. They shouldn't exist. The natural beekeepers, you may hate on them or love them, but they don't do any treatments. They don't go into their colonies at all. They should all have gone 10 years ago. They're increasing in number. They're doing really well. How can that be possible? And it's only through that the colonies must have some sort of resistance to survive. Otherwise, it'd have died out. Ask them these questions.
I was going to ask you, do you think there is a link between resistant bees and hygienic bees and low interfering beekeeping? Because I've been treatment free for about 8 to 10 years, and I think that went along with my low interfering beekeeping when I stopped using queen excluders, when I stopped changing their diet, when I stopped making decisions that they could make for themselves, giving them more space. I stopped knocking off queen cells, splitting them, uniting them, changing their diet, using foundations in the brood box. So I'm quite close to natural beekeeping, but I'm not a natural beekeeper, but I'm a low interfering beekeeper. And I would say, how can your bees develop hygienic behavior if you're in the hive every 5 minutes? So I think there is a link between hygienic bees and low interfering beekeeping in the sense that they can indulge their most basic instincts and be possibly stronger biologically.
Yeah, I mean, so you're correct. And I made a joke in Apimondia where they said, what was the biggest problem for Varroa and resistance? And I basically said, yeah, it was the beekeepers. But unfortunately, if everybody goes down that route, it's not for everybody. So the thing is, it's this transitioning away. How far you want to go down it, how much you want to go towards the natural type of beekeeping, that's an individual decision. And that's not for everybody. But basically managing this away, the transitioning away, once you've transitioned and stopped the sort of using the miticides, increase the hygienic behavior, then you can do other things, depending on what your feeling is and how you keep your bees. It's really good that people are doing this, but as I say, people who really want to change a little bit at a time and not go the whole hog straight away. Some people have, don't think it's for everybody, but I think it's, yeah, letting the bees do what they're really good at is great. But unfortunately, when you're locked into a treatment cycle, if you just step back and let them get on with it, you could lose your colonies. And that, for people with just a few colonies, 2 or 3, could be a real problem. So managing it away, I think, is a lot better.